So it's lithium. Lithium's the top of the alkali metals, the lightest of all of them. It's very, very reactive. We use it a lot in organic chemistry to activate carbon-carbon bond formation. But you can see here it's a very, very dark coloured metal. It's actually really nice and shiny if you cut it fresh, but it reacts with nitrogen in the air to form lithium nitride really, really quite quickly. So we're going to take a small sample, and again we're going to see what happens when we react it with water. Okay?
It has had a number of quite important applications in the last few years. Some of you will know that lithium is used treating what is now called in the bipolar disorder or manic depression.
The lithium itself is stored under oil to stop it reacting with the air and also with water. So we're just going to clean off all of the oil now before popping it into a sample of water. So here we have the dried lithium, which you can see as this metal, and we're going to drop it into the water and let's see what happens. Yeah. And it'll fizz around a little bit. So you see the lithium reacting quite rapidly with the water, and you can see hydrogen gas being evolved. Now if we catch that hydrogen gas in a beaker or in a test tube, we could then ignite it or burn it. You can see freshly cut lithium there, nice shiny metal. But as it reacts with the nitrogen, so Neil's got a sample of sodium. Sodium is a very reactive metal. It's stored under an oil to stop air or moisture getting on it, stop it oxidizing and stop it reacting. And you can see it's a very soft metal, so he's going to put his knife in and withdraw the lump of sodium. So there's about 2 kilos of sodium here. It's a really quite large rod. So we're going to cut a small sample of the sodium. Reacts very, very quickly with air and also with water. You form the oxide layer, which is the white, or the hydroxide is the white crust on the outside. So we're gonna go outside now to do some bigger reactions with some of the alkali metals. So here we have a bowl full of water and maybe a gram of sodium. So let's see what happens. See what this reaction's like. So it's reacting really, really quite quickly and really violently with the water. And you can see it's fizzing around as it's generating lots and lots of hydrogen gas. And see now the heat from the reaction is burning away all of that hydrogen which is generating, and you can see the orange sodium flame. Oh, it's on your camera. Oh, it is too.
Potassium metal is very reactive. One of my colleagues who used to work with it described it as evil.
It's a pretty big chunk of potassium, this.
Really?
Yeah.
Very satisfying reaction.
Like sodium, it's quite a low melting point metal, and if you mix sodium and potassium together to make so-called sodium-potassium amalgam, it's called NaC by those who work in the trade, Na for sodium, K for potassium. NaC is a liquid at room temperature. It looks a bit like mercury, a silvery liquid, but it's very light. And I've never played with it, but people say that if you try and drop it on the floor, it will burst into flames before it hits the floor because it reacts with the water in the air.